Hello. So when I was here last time, I created the backend for a IoT monitoring system where data would be pushed into MongoDB and then you could visualize the data using Atlas charts. This summer, I have built upon that and changed the architecture slightly. So as both an update on the changes I have made and a refresher, let's go through the um, architecture once more. If there are several IoT clients, they can push data into AWS, where AWS has a service called Lambda. This is a change from last time, and the reason we are using Lambda is because it's very hard to get an SQSQ to authorize IoT clients, as you would have to directly flash keys onto the IoT clients, and it's a little bit annoying. So I'm using this as an easier workaround. However, it doesn't limit the throughput at all, and it should still be as fast, if not faster, than the previous architecture. So yeah, what happens is the IoT clients take some JSON data and push it into Lambda, which is a service where a function is hosted on the cloud. And when it receives a JSON via post call, the function is run using that JSON as the input data. And all this function is doing is taking the input data and putting it into the SQSQ. From there, the architecture is the same. There's a fast API application which has several worker threads, all of which are serving as SQS listeners and taking the data and pushing it into MongoDB. Additionally, the fast API also handles GET calls from the website, which I will just go over in a second. And also on MongoDB, you have Atlas charts, which is how we are getting the iframes, which we will display in the website. Getting to the website has 3 pages: a home page, which for now is just a button which takes you to the locations page. However, it will be updated later. The locations page, which is a map view, which has markers on all the different locations which IoT clients are at. And finally, a specific page which is unique to each location, which shows you the chart for AQI of that location, as well as showing you this entire address of the location, how many devices are at that location, the last AQI, when it was last updated. So again, to get all of that information, it's making some GET calls to the fast API, which then queries MongoDB. And to get the iframe, it is getting that directly from MongoDB Atlas charts. To show you the website itself, this is the final page. However, if I go to the home page, you can see there's a single button which will be updated later. However, for now, this is the only thing on the home page. Then on the locations page, you can see the markers for where all IoT clients are. For now, this is some of these markers are dummy, which means there's no actual data at that location. IoT clients haven't recorded any data from these locations. And that's why when you click on some of them, they say no data. However, I have recorded data from Harold Frank Hall, which is this marker over here. And when you click on it, you can see the last AQI and when this AQI was last updated. Now, if you click on view details, you can see the entire address of that location. Once again, you can see the latest AQI as well as when it was recorded and how many devices are at that location. Before we get into this chart, just a little bit about the backend. The way we get this location is by having, when a new IoT client is created, it is the latitude and longitude of where it is uploaded, and then this location is got through reverse geocoding, which is where you take a latitude and longitude and get an address from the latitude and longitude. Then once all of this information is got, a device ID and a secret key for that device is generated, and put into a database which stores all the devices, where they are located, as well as the device ID and the secret key. And the idea is that eventually, when this becomes open source and anyone can add their own IoT devices to the system, we can authorize people through the device ID and secret key. However, that is not yet implemented. Now, to look at the chart itself, as you can see, it has AQI, PM10 and PM2.5. We can see that it's quite noisy, which is why eventually we might stop using MongoDB Atlas charts and use some other service where we can add a moving average. That will create more of a solid line, which may go down here, go up, and then go straight, instead of having all of this noise, which in the grand scheme of things, it's only 5 AQI points at its max, so it isn't a lot. And here you can see the PM2.5 and PM10, although they are overlapping in this particular graph. However, you can see a little bit of differentiation here. And when you hover over the graph, again, you can see the value, the time, and the what series it is. So you can see this particular data point is PM10, and it is a value of 1 on, you can see the time below, around 6:43. All right, that is everything I have done so far. Thank you for watching this video.